Today in college algebra, we're going to continue looking at coterminal angles, this time in terms of radians versus degrees. Yesterday we saw how coterminal angles were found by either adding or subtracting 360 degrees, so this time we have to do it with radians. Now the tricky part about that is we have to figure out what radian is equal to 360. So what we're going to do is convert 360 degrees to radians. So our conversion is multiply it by pi over 180. You have 360 over 180 degrees. You reduce the fraction, you'll end up with 2 pi. So now what we're going to do is rather than add or subtract 360 degrees to radians, which doesn't make sense, we're going to add or subtract 2 pi to our radian measures to find the other coterminal angles. This is how it works. So just like before in yesterday, we had an initial and a terminal side for our angle, and the distance between those was our measure. So in this case, we're going to call it pi over 6, which is a radian. Okay, now if we want to find the coterminal to this by continuing around the unit circle, right, counterclockwise, and ending up at the same terminal spot, we have to add 2 pi to our radian. Now this is the tricky part because students always mess this up because they want to put pi in their fractions and numbers when they're adding or subtracting. You don't do that. Okay, you don't need to use the pi button. It's not going to be anything good for you, so just don't. What you're in fact going to be doing is adding the fractions 1/6 and positive 2 together. So we have pi over 6 plus 2 pi. You get 1 over 6 plus 2 in a calculator. Find out what it is a decimal. Convert it into a radian. Okay, and it will end up being 13 pi over 6. So that's the coterminal to pi over 6. We added 2 pi to pi over 6 and got 13 pi over 6. Okay, we can do the same thing if we go back the other way. Let's say we wanted to go backwards on pi over 6 to find its reverse coterminal angle. All right, in this case, we're going to subtract 2 pi. Just like yesterday, we would have subtracted 360 degrees because we're going around the unit circle clockwise. So again, you're going to just subtract pi over 6 and 2 pi. Really, you're only doing 1/6 minus 2, finding its decimal equivalent and converting it into a fraction. Once you do that, you'll be getting negative 11 pi over 6. That is going to be our coterminal angle to pi over 6. Okay. Now in your notes, there's a bunch of different radian measures that you're supposed to find the coterminal for. So go ahead and do that. So pause the video and do that. Now, one of the keys to this is sometimes you might have to add or subtract 2 multiple times to get to the angle you need. All right, so go ahead and try that out. And when you're done, unpause it and we'll continue on. All right, so hopefully you're good and you found all the things. If not, make sure you ask some questions in class. All right, the next thing we're going to look at is finding the sine, cosine, and tangent of a terminal point. Okay. This is something that is very similar to what we did in the last unit, okay? But it has a lot to do with also just getting used to going around the unit circle. All right, so we're given a terminal point at -3, 4. That's where the point is located. So the -3 is the x value, so it goes along the x-axis, -3. So on the negative side of the x-axis. All right, then it goes up by 4 to hit the point. Okay. Now what we need to do is find that last side to make our triangle. Now to find this other side, all right, what you're going to do is use the Pythagorean Theorem. A squared plus b squared equals c squared. If you do it correctly, you should get 25 and take the square root of 25 and you will get 5. If you didn't get 5, it's because you didn't put -3 in parentheses before you squared it. So please make sure you do that. Okay. Now, in order to find where theta is, it's always going to be in the same place, as closest to the origin as it can get, which is going to be right there. All right. All you have to do now is use your right triangle trig stuff from first unit. The sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. And we just fill these out. So the sine at opposite over hypotenuse would be 4/5. The cosine would be adjacent over hypotenuse, which is -3 over 5. And the tangent of theta would be the opposite over adjacent, which is -4 over 3. Pretty straightforward. Okay. The troubling part comes when it's not a perfect Pythagorean triple, like the next one. Same idea. You're given a point. Here's our point. 3, comma, -8. So we go to the right by 3. We go down by 8, which gives you a -8. We have to find what the other side is going to be by, again, doing the Pythagorean Theorem. All right, 3 squared plus -8 squared is going to give you 73. Now, you can't take the square root of 73 because it's not a perfect square like 5 or 25 was in the last problem. So you just leave it as the square root of 73. That's it. Don't make a decimal. A lot of people the people that took the test, a lot of people left it as a decimal versus when you should have left it as a square root. So just stop right there. Square root of 73, you're done. Okay, as far as the triangle goes. Again, we need to find where theta is. And as I mentioned in the last slide, it's as close to the origin as you can get it. So you put it right there. Now for sine, we use the opposite over the hypotenuse. So you're going to get -8 over square root of 73. However, remember from the first unit, you can't leave the square root of in the bottom of a fraction in the denominator. So we have to multiply at the top, which gives us -8 square root of 73 over 73. With the cosine, we get 3 over the square root of 73. Again, not allowed to leave a square root in the bottom of a fraction. So you rationalize the denominator and multiply the square root of 73 to the top. And you get 3 square root of 73 over 73. And lastly, tangent, opposite over adjacent, is going to be -8 over 3. Okay? And that's all you have to do for those problems. All right, there are 2 more examples in your notes. Please try those examples so that if you're having questions, we can ask them during the Zoom. All right, good luck.